And we are on. Yes, we are on live. Give it a couple more minutes. I'm going to start right at the 4:30 p.m. dot. Looking good. Okay, we got an excellent connection. And one of these days we got to do a clip at. Okay, and we got an excellent connection going. I'm going to start right at the 4:30 p.m. Eastern Time dot. Bitrate is looking good. And we are on. Hello, everyone. Hello. Thank you for tuning in. Thank you for joining me today. This is Introduction to Security, offered at Tufts University. I'm Ming Chow, Associate Teaching Professor. Before I begin today, I want to give a shout out to Chris Krebs, now former Director of the Cybersecurity and Infrastructure Security Agency, CISA, as part of the Department of Homeland Security. I want to say thank you, Chris. Thank you so much for your service, your hard work, your service to the country. Thank you so much. I also want to put on the table for Chris that you are always welcome to give a guest talk to my security class. Just let me know. The red carpet will be rolled out for you. The offer is always on the table, my friend. Thank you, Chris. Thank you so much for everything that you've done. So today, another bit of announcement before I begin is something I will be using today is the latest version of Kali Linux was released yesterday. Kali Linux 2020.4.4 release. The biggest change and the biggest difference is the shell. It is now using ZSH. Okay, so a whole number of changes. Now ZSH by default. I've been using it for the last few days, and I'm really getting into the hang of using ZSH. And you'll see today that my shell, I'm going to be using Kali today for a very good reason. I'm going to be using Kali today for a very good reason because we're going to do malware. We're going to work with malware today. Live malware, yes. So that leads to what we're going to do today, and of course why I'm going to use Kali Linux is today we'll be on malware, specifically backdoors. We're going to go over basic definitions. We're actually going to open up and use a real backdoor so you can see the effects of using a backdoor. We're going to run that back. We're going to scan that backdoor by way of VirusTotal, and we're even going to use a hex editor to perhaps, is there a way to fool detection? A way that we can do that. So in short, what malware is malicious software. And there are many different types of malware. Viruses, worms, Trojan horses, ransomware, backdoors, rootkits, and the list goes on. When people ask me what is a good resource to learn about malware, the first place that I tell people to go to is Malware Unicorns Reverse Engineering 101 online course. It's at https://malwareunicorn.org/workshop/re101.html. This is a free and open source course created by Malware Unicorn herself. Want to give a shout out to Malware Unicorn. Thank you so much. Hope you're doing well. You built this a number of years ago. But this is a reverse engineering course. A reverse engineering course that's targeted to reverse engineering malware. Interestingly enough, now that I'm bringing this up, she's also, when we get back in the past, in person, she's done workshops at DEF CON at the Packet Hacking Village for us, and it's always sold out immediately. So this is a free and open source, free course that she put together, and as you'll see in a few minutes why I brought this up as well. And of course, this workshop provides the fundamentals of reverse engineering, Windows malware using hands-on experience with real reverse engineering tools and techniques. She does quite a bit. So this is what you're going to learn, what you will need. I like this. I'm going to blow up the font a little bit. What is reverse engineer or reverse engineering? And we're going to do a little bit of this today. It's a process of extracting knowledge or design information from anything man-made and reproducing it or reproducing anything based on the extracted information. Like, what does it mean to do reverse engineering? You can. The analysis flow for malware analysis, and this is something I want to bring up. The analysis flow for malware analysis. Set up a baseline analysis environment using virtual machines. Triage just to determine a starting point. Here's the big one. Static analysis. Get a sense of where everything is before debugging. Dynamic analysis. Determine behaviors that can't be understood by static analysis. And now, you may be wondering why this course was designed and organized the way it has been for years. I mean, if you remember, if you've been tuning in to all these episodes from day one, it started out with networking, attacking networks, sniffing, scanning, cryptography, vulnerabilities, web security. We even played a capture the flag game in my security course. Last week, we did static analysis, and also we touched upon dynamic analysis as well too. And all those topics all lead up to malware analysis. Do you need to know a lot to do static before doing static analysis? Before doing malware analysis? The answer is yes. So now you have an understanding that why I've structured my security course the way it has been. So of course, like last week's static and dynamic analysis, and then a lot of networking, a lot of other topics, like including networking, cryptography, web security, they all tie in to today, what I'm going to talk about with malware and malware analysis. Manual debugging, stepping through the program to navigate your goals. She even goes through the environment setup, anatomy of a Windows portable executable C program, touched upon assembly language and x86. This slide, 6, attack flow. This should look familiar. Reconnaissance, exploitation, infiltration, internal reconnaissance, entrenchment, command and control, exfiltration, and purge. You see a lot of, should see a lot of very familiar terminology from the previous weeks. And terminology is important, especially when it comes to malware classes. Like a virus that replicates a process system with user intervention. And that's the key, with user intervention. A worm is code that self-propagates across system without requiring user intervention. Human gets into, you have a lot of other classes of what I call families of malware: bot, Trojan, ransomware, rootkit, rat, dropper, adware. The one that we want to focus on today is this. The one type of malware that I want to focus on today is a backdoor. So what a backdoor is, it enables, well, word for word, it says enables a remote attacker to have access to or send commands to a compromised computer. So here's the significance of backdoors. Once you have a backdoor on a computer, install all the protections, including all the greatest cryptography, all the greatest security, passwords, whatever, all gets bypassed. I repeat, once you have a backdoor on a system, all the security mechanism gone. Completely gone. Useless. That's how critical a backdoor is. And I want to focus on backdoors today because of another reason. Is not because it's only a type of malware, but also because it's been a big topic of discussion when it comes to national and international security. Well, you may have heard about cryptographic backdoors, or that the government wants backdoor access to your systems. And here, this has been an age-old debate. It ties in, it's the same concept. The whole idea of a backdoor in malware is practically the same concept as the backdoor the backdoors in the encryption debate. And so here's an article from the EFF, the Electronic Frontier Foundation. It says governments around the world keep trying to break encryption, seeking to enhance the power of their law enforcement agencies. They've tried for years to require companies to build. Here's the key. They tried for years to require companies to build backdoors into encrypted software and devices, which would enable them to listen in on potentially any digital conversation. The FBI is kind of going dark. But encryption with special access for a select group isn't some kind of superpower, it's just broken encryption. The same security flaws, will be used by basically anyone else. So the whole topic of backdoors it goes way beyond just malware. It also transcends into a national and international debate. So it's important to understand not only the terminology, but also how dangerous backdoors can be, which I will demonstrate today. Long article. Thanks to the EFF for all their work. But today, let's use a backdoor. So there is a backdoor that I absolutely love, the malware type that I absolutely love to use and demonstrate because it's just seemingly so simple. And the variant of a backdoor malware that we're going to play with today is called Tini, T-I-N-I. That is T-I-N-I. I found this is when I was going to boot camp over 10 years ago, this was the backdoor piece of malware that we use. And I found this on archive.org. The original website, ntsecurity.nu, has migrated to a new domain. But this page was up for years. And I did find this on the Internet Wayback Machine. So what this backdoor is for Windows only. Um, the page is still available on the Wayback Machine. It's well over 10 years old. And it is called Teeny or Tiny, Tini. It's a very simple and very small backdoor, 3 kilobytes for Windows, coded in assembler. How it works is it listens at TCP port 7777 and gives anybody who connects a remote command prompt. So this is a very real and very small backdoor that is for Windows. And here's the usage instruction. Download the exe file and run it. Connect with an ordinary telnet client or similar, like Netcat, to TCP port 7777 and press enter once. Now you will see the command prompt and will be able to type the command. If you go to this, if you go to the Wayback Machine and you go to this page, I believe you can still download it. Can you still download this? And ooh, maybe. Yep, you can. So the download will be tini.exe. Cool. So it's still available. This is still available on the Wayback Machine. All right. Now, of course, if you try to go to the actual website today, it doesn't exist. So the only way that you can get that piece of malware, the Teeny malware, is by way of going to the Wayback Machine. And there's been a lot written about Teeny in the past. If you just do a search for Teeny right now, it's going to bring back a lot of results. This is a very well-known piece of malware, backdoor, that has been analyzed. But for demonstration purposes, it's also a very good exercise to show. And also, especially for today, how dangerous a backdoor can be. Okay, so what I'm going to do now is I'm going to fire up, I'm going to open up a few machines on my home lab. And I want to continue. I'm going to fire up my Kali Linux first. Cool. And there it is. Here is the newest version. This is how the brand new version of Kali looks like. Can I enlarge the window? Yeah, I can enlarge the window a little bit. Now, I do have a collection, and of course I'm firing up the command line terminal now, and this is how ZSH looks now. I have a collection of malware on this machine. A lot of the malware, a lot of it is downloaded on, it's available on GitHub. A lot of the malware, especially like the Android stuff that I study and work with, are all on GitHub, all available on GitHub. But I also do have a copy of Teeny. I do have a copy of the Teeny malware. It's in teeny.zip. Okay, so notice it's a teeny.zip, not an exe file. And you'll see in a moment why. So I have an instance of Kali Linux running on my home lab. And now I also want to fire up Windows 7. Yes, I want to fire up Windows 7. So what we're going to do is this. What we're going to do now is I'm going to log into Windows 7 and I'm going to install Teeny on this Windows 7 machine. And then I'm going to open up that malware in Windows 7, run it. And then on Kali Linux, I'm going to connect to the Windows 7 box at port 7777 so I can get a backdoor access to Windows 7. If I log into Windows, okay, here we are. I can't get my mouse out. Okay, so I got an instance of Windows open, and I also have an instance of Kali open here. Yep, there is a new Kali Linux update as of yesterday. Yes, as of yesterday. So I'm on a home lab. So I have Windows 7 on the left and Kali on the right. So I need some way to get the teeny malware on to Windows 7 instance. One way I can do this is I can set up a temporary web server that serves this entire malware folder that I can serve this entire folder, let's say by way of the web. And it's only accessible to those computers that is on my home network. So what you can do is, there is a simple way, and this is actually a really nice trick. If you ever need to temporarily serve a folder onto the web so your web browser can have access to it, is to run Python 3 minus m http.server. And what this will do, it will actually serve HTTP on, well, your IP address at port 8000. And so it will, the entire folder, your current folder that you're working on, in this case is going to be my malware folder on Kali Linux, will be served onto the web. Alright, now with that done, I'm going to open up Chrome on Windows 7. Just a little heads up, this is probably not going to work, and you will see why. But I do want to point this out. So I can go to HTTP. The name of this server right now, I can do, oh, what's the IP address on this thing? Hold on. What's the IP address on this Kali Linux? 211. 192.168.1.211. Okay? 192.168.1.211. Oh, very important. It's at port 8000, not port 80. So I'm going to do a colon 8000. See what happens. Ooh, cool. So now my Windows 7 box is accessing the malware folder that got served on Kali Linux. Cool. All right then, let's see if we can download teeny.zip. So to try out this piece of malware, we just want to download it, right? Hello. There we go. I'm going to save this to my desktop. td.zip. Yep, looks good. Now you hit save and watch what happens. 3 kilobytes. Ooh. Okay, stop right there. So one of the things is, a lot of modern web browsers and operating systems, this is such a well-known piece of malware that a lot of web browsers and systems will flag it automatically. So now I have now I got a warning on Windows 7 that potentially harmful software detected. Click to review or take action. I'm gonna, I'm too late. That thing is, okay, I'm too late. I try it again. Save it to my desktop. teeny.zip. Still failed. Come on, is there a way that I can actually resume or something? No? Well, it looks like I'm SOL. Oops. It looks like I'm SOL and trying to download this piece of malware. I mean, it got flagged by Windows 7 and by my web browser. It's not good. Not good. So is there another way to download this piece of malware from Kali onto the Windows 7 box? Well, yeah, there is another way. I mean, okay, so it doesn't work on a web server, but let's see if we can actually, well, use like SCP, Secure File Transfer Protocol. 192.168.1.211. The username is password. Now I'm going to connect on Windows 7 directly to the Kali machine. See if that works. Alright, looks good to me. Okay, now I'm going to go to my desktop. There's a really old version of WinSCP. Oh, malware. Teeny.zip, there where I can move it over. Yep. Alright, looks like that worked. Looks like that worked. Alright, now this piece of malware I deliberately named as a .zip file because I didn't want the system to just flag it automatically. So now, teeny.zip. Is there a way that I can make it an executable? And the answer is yeah. Now that I have successfully downloaded the teeny malware onto my desktop, next thing is I want to rename the file. So it's now, I'm going to change it from teeny.zip to teeny.exe, the executable for Windows, which was the original name of the file that was on the NT Security website. Alright, looks like I'm good. Let's terminate the session. So I got the teeny piece of malware here that's running. Oh, very important. Very important. Next step is, okay, so I got the piece of malware on Windows 7. What's the IP address of this Windows box? I'm going to open up a command prompt, cmd.exe, ipconfig. Alright, the IP address of this Windows box is 192.168.1.203. Cool. I'm going to go back onto the Windows machine, onto the Kali Linux machine now. I'm going to clear the screen. Ping 192.168.1.203. Yep, it looks like I can do it. Now, as you remember from the documentation on that NT Security website, Teeny will open up at port 777747. You can use like Telnet or you can use Netcat to connect to it. Okay? Now, what I haven't done yet is I haven't opened up teeny.exe yet. I have not opened the teeny.exe program yet, the application that's on Windows, that's here. I haven't opened this yet. But let's say right now, I'm going to clear the screen. I'm going to do netcat 192.168.1.203 and then at 7777. Let's see if it does anything right now. Well, connection refused. Connection refused. Alright. Connection refused. Okay, now it's time to open up the piece of malware. Let's double click on teeny.exe. Oop, let me close out this. I don't need this. Double click on it. And you can see my icon on my mouse is circling. And it stopped. Okay. Alright. Looks good. Right? Well, that was simple. So what happened? Well, what do we do now? No pop-up window, no nothing. Then again, you shouldn't expect anything because it's only 3 kilobytes. Here, I'm going to go back to Kali Linux. Remember what we were doing for the last moments ago? We tried to connect to the IP address to the Windows box at port 7777. See what happens now. after I opened teeny.exe on the Windows box. Okay. Well, there you go. It's holding. Oh, yes. I remember in the documentation it says on that page you have to click the Enter key again. Twice. Yeah, I want to see more. Boom. And here we go. We got a command prompt. We got shell to the Windows 7 machine. That means you can do whatever you want? Oh, yeah. To prove that teeny.exe is a backdoor, and it grants you a command prompt shell, and hence I have access to the Windows 7 box that is running, what can I do? Well, the age-old trick, try to fire up the calculator. Type calc.exe. So I'm on Kali Linux now. I just netcat to the Windows 7 box, 7777. What they call this popping calculator. See what happens when I type calc.exe. There you go. And now, because the Windows 7 box is completely backdoor now, I have backdoor access, I can do whatever I want. Aha! Really? I can do whatever I... Wait a minute, why the hell did I just got this? Okay. Wait a minute. Really? I can do whatever I want on it? Of course. And I'm going to actually go on my desktop. I'm actually going to put a simple text file on the desktop. Watch what happens. So I'm going to create a text file called hacked1.txt, and it's just going to create a text file with, see what happens. Cat is not a, oh, echo. Really? Okay. Create another file. Ouch. Boom. Really? Did it really create those files? Well, let's touch the Windows box now. Let's look at what hacked 1 is. Got that message? What about this hack 2 thing? Ouch. Hack 3.txt. Backdoor. Now I can go to system. Hold on. I can even go reverse any directory. CD Windows. There. I can take a look at any file on the system that I want. Of course, can I actually delete the file, all the files? Of course I can. I can just do del. I'm not going to do that just yet. But you get the idea. So now, because Teeny is running, I got full backdoor access now to the Windows 7 box. Yep. All right. I want to come back to. Let's have some fun a little bit later. I want to quit out of this for a second, but now I want to enlarge my Kali machine. I'm going to go back to the Windows 7 machine. But one thing I want to do now is I'm on Kali. I want to open up a web browser and want to analyze that piece of malware, in this case teeny.exe or teeny.zip, using VirusTotal. Go to virustotal.com. And what VirusTotal is, it's a service to analyze suspicious files, URLs for malware or anything malicious. So you can upload a file, you can even send a URL, you can even do search. So now what I want to do is I want to upload on Kali, the teeny.zip that's in my malware collection. Go to home, go to malware. Yeah, I'm going to upload teeny.zip, that 3 kilobyte piece of malware, a backdoor. And is it? Ooh. And as you can see, VirusTotal, once it got uploaded and sent to VirusTotal immediately, 63 out of 72 antivirus engine detected the file as malware. That's a lot. 63 out of 72 is extremely high. It's an extremely high, yeah, it's malware. So let's see. Here are all the antivirus engine: ClamAV, Win.Trojan.Tiny, Cyber Malicious. Yeah, generally speaking, a majority. F-Secure called it a backdoor. Malwarebytes backdoor. Microsoft calls it a backdoor. Trojan, backdoor. And you have these antivirus engines that did not detect it. Interesting. 63 out of 72 is extremely high. You can even get more details. Got details like the basic properties, like the checksum of the file, the hash value, magic. Ooh, you can even see the type of file it is. It's a Windows program. Creation time, a long time ago, 2000. Other names of this piece of malware goes by all these different names. Portable executable information, all this stuff. Again, for more details on learning about portable executable environments, go to Malware Unicorn's online course. Target machine Intel 386 or later processors, imports, lots of details. Okay, any relationships? Oh yeah, this piece of malware has been scanned many, many times in the past. Relationship with other malware that had been submitted to VirusTotal. Lots of stuff here. Shell command, yada, 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 yada. And the list goes on. Community information from people. Yep, old relic. It certainly is, but it's a great learning tool as well, too. So VirusTotal does great detection of the malware. Yep, and here are all the ones that failed again. Oh yes. Alright, so now there's another question. So, okay, what can we do now? So now we've done backdoors, teeny, we even did demonstration. Now you're seeing the information on VirusTotal. Oh yes, this is a real piece of malware that's been very, very well known. So now the question is, okay, we have the original teeny.exe. Is there a way, what happens if you take that original piece of malware, that teeny.exe or teeny.zip in my case, can you, oh, let's see, can you change the behavior of the malware and perhaps even fool VirusTotal? Yeah, let's do that. Let's do that. So what we're going to do next is, let's see if we can modify the teeny malware to some different behavior. Instead of opening on port 7777, we open teeny on some other port. And we make that modification. Will the result be any different on VirusTotal too? So that's what we're going to do. So I'm going to come back to VirusTotal, not now. But what I want to do is first go to the malware folder, and I'm going to rename, make a copy of teeny.zip, and this time I'm going to have, I'm going to rename it to Fortnite.exe. So I'm going to make a copy of teeny.zip or teeny.exe really as Fortnite.exe. Okay? And the next thing I want to do is there a way that I can make changes to Fortnite.exe so instead of it opening up a shell at port 7777, it opens it up on some other port number? Can we do that? And the answer is yes. One way that you can perhaps do that, and in this case it may be easy for us because Teeny was written in assembly, is to open up Fortnite.exe in what is called a hex editor. So you can update the low-level information and then you can save and overwrite, make a new copy of it. That could work. So I want to actually go here to DuckDuckGo and let's go to Linux hex editors. What are the best hex editors out there? I'll go to this one, the 10 best Linux hex editors. Okay, so what a hex editor is a program that allows the user to view, edit, and manipulate binary files which contain data that is readable by machines but not humans. This is where hex editor comes into play because unlike other programs and tools which interpret data from files, hex editors, on the other hand, offer the user an opportunity to edit the physical binary contents of a file. Cool. Cool. All right. Fortnite is secretly malware. And this is, of course, how people usually do scams and all this stuff. Okay, I see number one is something called Bless. Oh, all right. I think I got Bless installed here. So I'm going to open up Bless. Cool. Oh, so actually it did open up Bless before, but it now open up to teeny.zip. Okay, I'm going to close this out. But now I want to open up Fortnite.exe, which I was a copy of. Oh, okay. So now, using a hex editor, you can actually see all the low-level details, all 3 kilobytes of it. And interestingly here on the right, you can see, like, this program cannot be run in DOS mode, versus, yada, 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 okay? And you can even see things like winsock32.dll, cmd.exe. Interesting. You can see some human readable information. But what we want to do with this Fortnite.exe app is we want to find the value, because remember, Teeny opens up at port number 7777. We want to find in this binary where 7777 is and then change it to some other number. But here, remember, all these values are in hexadecimal, not decimal. Okay, these are all hexadecimal value. So what we want to do first is in order to find 7777 and where this is here, we need to convert 777. Oh, it crashed. Damn. Do this again. Let's go to find the value 7777 in hex. So I'm going to open up a web browser 7777 from decimal to hex. And I'm going to use some decimal to binary convert because I can't do it on my head. Decimal number 7777. And that can be, okay, so the value that we need to find in the hex editor is 1E61. That is 1E61. Can we find that? So I'm going to find 1E61. Is that anywhere here? Yes, it's right there. 1E61. And now let's change it to a different value. Okay, let's change it to something like, I don't know, 6767. Okay, like 6. Yeah, let's do 6785. I don't know. 6780. Let's do that. That is our new port number, 6780. So we need to change that 1E6, what is it? 1E61 to 1A7C. Okay? 1A7C. No, I want 7C. Come on. 1A7. Hello? No, it's not letting me do it. Let's go. 1A. 7C. I don't know why it's not giving me the ability to do so. I don't know why it's not letting me do that. Okay. Okay, so I'm going to do a find and replace. 1E, I should have done that. 1E61 to 1A7C. See if that works. So replace 1E61, which is 7777, in decimal to 6780, which is 1A7C. Let's see what happens. Pattern was not found. What are you talking about? It was right there. Oh, replace. 1E61. Pattern was not found. Can I do a replace now? Replace with 1A7C. Yeah, there you go. That took a long, I don't know what that was. I'm going to save this now. Bingo. Oops. Looks like I overwrote the original teeny.zip. Okay, but that's okay. That's okay. That's okay. That's okay. I overwrote the original teeny.zip. That's okay. So I'm going to move Fortnite. I'm going to move teeny.zip into something called temp. Move Fortnite.exe into teeny.zip. and I'm going to move temp to be Fortnite.exe. All right, that would solve our problems. Now, first of all, what we're going to do now, we can do a diff. Oh, I'm going to clear the screen. I'm going to do a diff teeny.zip and a Fortnite.exe. Are there any differences? Yep, binary files, teeny.zip, Fortnite differ. All right, let's go to a web browser. Open up VirusTotal. Choose file. I'm going to go and go to malware. First of all, let's review ourselves. All right, this was teeny.exe. 63 out of a 72. So keep that number in mind, 63. But we made a copy of teeny.exe, or teeny, into Fortnite.exe. And we just changed the port number from 7777 to 6780. So what happens now if we upload Fortnite.exe? Will there be any changes? Will the detection ratio be different? Take a look. Is it 63 again? Still going. Well, it stopped at 49. So, okay. 49 is still a big number. So it's still malware, but the big difference is now it's not 63 engines detected the piece of malware. It's 49. So who didn't detect it? There's a whole bunch of engine that didn't detect it this time. Interesting. So we went from 63 to 49. That's not, well, I mean, it's still malware. 49 is still a huge number, but not as big as 63. Interesting. So when you make a small edit, to a piece of software, in this case a piece of malware, yeah, it can throw off the detection a little bit. Not by much, but a little bit. But we'll run now. Will this fake, this piece of malware, which we renamed as Fortnite.exe, will that work now on Windows? Well, let's take a look. Go back to Windows. I still got it running, but this time I'm going to delete all these files. I'm going to try again. Okay, you know what? Pretty safe to go. Restart. Okay, so I got Teeny still here. Now I'm rebooted. Empty the recycling bin. Cool. Now, going back to Kali Linux. Can we still do a netcat to the Windows box of 777? No, refused. So Teeny is no longer running on the Windows 7 machine. But now we want to download a fake version of the Fortnite malware that we had here. Okay. WinSCP. Username. Oh, yes. Okay. I'm going to my desktop. Yeah, backdoors are not good. Go to malware. Now I want to make a copy, bring that over. No problem this time. Now if I run this piece of malware, let's see what happens. Okay? Like the last time, it runs. No pop-up window, no nothing. Now remember what we did. We changed the port number from 7777 to 6780 on the piece of malware. Now on Kali Linux, I'm going to go and connect up port 777. Shouldn't work. Nope. Should not work. But instead of using connecting at port 7777, which the malware originally opened, let's use a new port number, which we had was 6780. Will that work? Ready? So instead of connecting to port 7777, let's connect to 6780. Using a hex editor and changing 1E61 to 1A7C, looks like it has some effect. Oh, out of print, enter again. Boom. Yep. The modification worked. Calc.exe. Boom. Up. Echo. Hello. Yep. Alright, now for the grand finale. Okay, now I can do it. Because I'm ready to close today. Let's see if I go to CDC. Go to dir. CD Windows. Gotta go to dir. Okay, now that I have direct access to the entire system by way of a backdoor, can I just delete everything? Go star. Yeah, I'm sure. Oh, I got access denied though. Okay, so it deleted a lot of files, but not the important ones. Alright, but yeah, the del star can work. Yeah, it can work. Access denied, but hey, if I do a dir now, it looks like a lot smaller. Okay, so del star did work, but I don't know what files got deleted. Oh, let's go to CDC. CD desktop. Oh, CD users. CD defcon. Desktop. Del hacked.txt. Can that work? That's gone. Ink droppings. Cool. Backdoors, not good. So in this case, yeah. So what we've gone over today, quite a lot of things. I showed you the latest version of Kali, malware unicorn reverse engineering tutorial, why backdoors are important, because it's not only because of malware, but also because of the national and international debate on crypto backdoors. I showed a real piece of malware, which is a backdoor called Teeny, the VirusTotal. I even showed VirusTotal. Did a demonstration of how to even make a simple modification to a piece of malware using a hex editor. Rerunning that, rescanning that in VirusTotal, and here we are. And that's it. And folks, that's it for today. So thank you so much, and there will be no live session next week. Happy Thanksgiving to all. Take care.